This is my second quarter at National Instruments, and basically at this point in time we get to do our intern projects, which is 1 week out of work and we get to make whatever we want with National Instruments hardware and a small budget. And so this week, well, this video is going to be on my intern project. So our project is a two-part project, and one part is going to make a load of motion mines. What they do is they're wireless and battery powered, and you put them around an area, and as soon as one goes off, it sends off a signal. And the other part is a drone. It's my part, and the drone will then find which motion mine has kind of gone off, or fly to that position, and well, film the area and send back some video automatically. So we're going to use LabVIEW to make it, and it's going to be a bit of a push because we've got 1 week and we're supposed to do something that's doable in 1 week, and there's concerns that you can't do that in 1 week, so we've got some pressure on us. So yeah, it's going to be fun, and we're going to do a vlog at the same time. So you can choose to work in teams, and Timos is working at my team. Timos, what's your part of the project?
Hey guys, so I'll be working on interfacing all the third-party hardware with my Rio. So I'll be working on kind of the motion sensors and interfacing the wireless modules, just doing all the wireless stuff essentially.
Nice.
So Mr. Dan here is measuring out the wire for the antennas for our wireless modules.
We're going for a full wavelength antenna for the max distance. So now I'm in the car. I've set up the Arduino in the car and the radio transmitter. We're going to do a range test, sending texts to each other. But yeah, I'll call them up. I'll drive, stop somewhere, then do a test, drive further, stop somewhere. Hopefully we can get, a range. Obviously there's going to be a lot of buildings in the way. The antenna is just up there, so I'm going that way, and it's on a window, so yes, we'll have line of sight for a while, and then we'll have a lot of things in the way. I'm just going to go for a drive now, alright?
Where are you now?
I'm just pulling out of the car park. I had to sellotape the antenna on.
Okay.
I'm just going to go down the road to the end of the street.
Okay. Send me number one.
Number one? You send me something back.
I'll send you number one.
Oh yeah.
This is a response.
Okay. Keep going.
Keep going.
So today we did some C coding. We've got everything communicating automatically. How's it been going?
Yeah, pretty well. We've got all the wireless modules working, and we should be able to make a grid with them tomorrow, but we'll see. Looking good.
So it's day 2, and I've managed to get LabVIEW to communicate to my drone. So my drone works with these files. They're uploaded into the drone with different waypoints, GPS coordinates, and I've decoded it, and we're just sending it with an array. Now the drone is quite an old one, made out of wood. It's balsa wood, so it actually is light, and we made this about 3 or 4 years ago, so we'll see how it goes. We made it in high school and A levels.
Take 2.
Think of doing a GPS test now, shall we?
Sure, let's go
Okay,
for
we'll
it.
keep it high just in case it goes crazy. and I'm going to put into GPS mode. Sometimes it goes crazy in this mode. Ready? Okay, there you go, it's balancing itself. Oh sick, it's working! Okay. It's a little scary, eh? So before we go out, Tim is doing some last minute testing down there. Sorry. And with a bit of a problem, we don't have an antenna for one of them. So I've come up with a solution. We're going to use paper straws and, you know, glue them together to make one long antennae. It's a last minute decision that I've made. Here we have an industry standard golden antenna made by paper, and we have some industry standard reinforcing there. Just make sure that everything stands up nice and strong. So the point of this test is to use our awesome sensor modules, and when motion goes past one, it needs to detect it, send it back to the ground station, tell this guy to take off, and we've got some fail-safe measures so that it'll ask, do you want to send the drone? We'll hit enter, and it should just automatically take off, fly to the sensor, and then come back and land. So these are the sensors. We are right down at the bottom here, and our home point is just below sensor 2, and we're going to go for sensor 0 right there. Ooh dear, it got dark there. And hopefully flies there and flies back.
Put like this.
You pick it up when it starts flying away.
Okay.
You ready?
Yeah.
It's upside down, twist. There you go. Look at the camera, it's working! Sick! Okay. It's working. Although it's... yeah. Actually going to the point in the middle. Now it's not. So after that test, we actually passed the first test, which was when an intruder or when the sensor was detected motion, could the drone actually fly that way? And yes, it worked. It flew straight to the sensor and everything was good. But after it got to the sensor, the problem was it didn't come back. So we had it coded so that it would fly home to its home position, and its home position, I think the coordinates and the coding wasn't done correctly. I might have had a little bit of bug in my code. And so that's something to work on. And actually there's a ton of things you really need to add to this to make it a working product. So I'll list those in a minute. But yeah, it was a really good run that week. Had a lot of fun with LabVIEW, and it's definitely a really good piece of software to use if you want to get something working really quickly. So here's a list of a few things we'd like to add, and it'll be amazing, and I don't think we'll be able to add these at the moment, but you've got auto GPS and safety check. So we saw that thing where it said, do you want to send in the drone? You said okay, and you'd basically check everything yourself. It'd be great if it would just check if everything was safe and then it would just fly by itself. The second thing would be an awesome vision landing system. So at the moment it lands with GPS, and it would probably just land up to a meter from where it took off. What we really want is a landing system where it has a box that opens up and it lands really accurately using a lot of cameras. And LabVIEW has the vision toolkit. We could perfectly easily design that with LabVIEW, and then you can have some other cool things like a strobe light to flash, to be a bit scary, a thermal camera to see anyone in the bushes, obstacle avoidance so you don't hit anything, or even a mapping of the area so that it would avoid certain areas, make it a certain route. Follow locking feature, so once it gets there it would lock onto that person, whether that would be a design in the actual drone or something that would track someone using vibration in the ground. And then an animal vs human detection. That's quite important because on a big rural area you're going to have like a farmland area, you would have a load of animals and they probably trigger those sensors. So there's a lot of things you can add to this to make it a real fully functional system, but I guess in a week we can't do that, we can't get anywhere near that, and it was just a lot of fun. So thanks for joining us for the ride, it was awesome, and see you later.